Hey, welcome back to the tools track. Here we have Nikolay, who will be helping us survive UA automation Armageddon. He is a team lead at Automate the Planet and lecturer at Telerik Academy. Over the last 10 years, he's gone from zero at the Academy to a principal QA. So I'm really looking forward to hear what he's got in store for us today. Over to you.
Yeah, thanks, Lewis. I'm really happy to have you all on this talk. I'm quite excited to share this with all of you because it has been wandering in my head for quite some time, and I was wondering how to put it the best way. So, as Lewis said, my name is Nikolay Avramov, and I'm a developer and test lead at Automate the Planet. So, I will jump to the agenda and I'll tell you about this story I'm going to show you today. This is a story about building a large scale automation project that we worked on for a couple of years now. It's about the framework that we use and the specifics that it has of its usage and how we actually put them to work. The project's enhancement we made up on top of it, and at some point the fact that we saw some really big change and issue in the front of us, which asked us to question the use of the framework and all the implementations that we did to enhance our work. So I'm going to show you the plan that we took, the actions that were executed, and the final result. So I will jump straight to this because there's a lot I want to show you. First, I'll start with some context. So, the product that we were testing is a web-based cloud system, really large scale, with consisting of more than 2,500 screens, containing mostly forms and grids and some specific functionalities around them. So they're like typical screens with lots of fields and some grids, but inside of them they have lots of um, business logic, which is even further customized with adding some settings, which are serving as toggles. This is pretty common for such cloud systems where you want specific behavior for different customers, but it's not making the testing easy at all. So the system is built on top of 16 applications that share multiple database servers. The backend is written in C Sharp, ASP.NET, MVC, and for frontend, they have some libraries that they use across the whole application. Of course, we have some custom logic on the front end, but this is the overall info, and it's just to imagine the scale of this. So when you work on some project, of course, you have to consider the scale and how much you want to expand your test automation and how much of this you want to cover. So in our case, we did some similar structure as here on the slide. We had about three main suites that we implemented for this large project. The first one was actually consisting of about 1,500 UI component tests. This is a very critical part of the system, and this is where we started, because when you have such a large distribution of components, you really want to make sure you're testing them for regression when it comes to upgrading or changing the control vendors. So these tests, the components tests that we have, are living in separate applications, and we just execute the tests against them and verify that any user can work with them. The next step was actually to implement sanity tests for the whole system. Sanity tests in our scenario are representing simply a load of a screen from the system, which is making sure that the page is loading correctly, there are no problems with the rendering of the page, and also there are no errors or any components that seem to be broken on the page. So these are just pages that tests that go through all the pages of the system and make sure the rendering is correct and the pages and the functionalities are accessible to the users. The third type of tests that we designed here were the system tests. And these are quite different from the first two. Why? Well, because the system tests are consisting of lots of test data. Um, their aim is to test business scenarios on the whole application, and they're going through multiple screens, executing and verifying a business use case for the system. So these tests are their count. We have it here is 7,000. It's actually bigger, but that's not so important. The scale is pretty big. We still try to make them focused, and with that much pages and components, we really were trying to make them repeatable and really well maintainable. The test execution is, I would say, pretty standard. In our case, we're executing tests in Jenkins. The pipelines or the jobs are triggered from Azure DevOps, and the results are reported back to it. So we have scheduled daily runs. The whole execution, which is pretty big, is taking about 20 hours for the whole day running, but we have results on the other day, which we can execute and analyze. So the test automation suite is based on the BELLATRIX framework. This is, you can see that from the title of the talk, but I want to elaborate a bit on what is a framework and why we are saying that it's a framework built on top of Selenium. Probably many of you know what's the difference between these two, but Selenium is actually not a framework. Selenium is a library that helps us to work with the browser and to simulate the user inputs on the computer. Stuff like clicking, moving your mouse if you want, typing text, navigating to a particular page. These are like the functions that Selenium is giving us, but it's not a framework. The framework should provide some additional controls and extensibility over the standard ways we use Selenium. It's also abstracting some ways to work with pages, with components, with page actions, which are more specific, and we need some easy way to use them instead of writing long methods about it. The framework also has some built-in weights, conditions, assertions, lots of helper methods that um, enable us to write more quickly our tests and not to worry too much about the small inconsistencies for weights and for different flakiness in our project. In the case of Bellatrix, it's incorporating most of the quality code design patterns inside of it, and having a framework which is built like that, it's really inviting you to do it the same way in your tests. It's of course not a requirement. You can write as you feel you should write it your code, but having the framework built in such a way is really helping to keep this quality code across the whole test project. Another benefit of this is when you invite some developer or someone from the team that can help implement some more complex feature, let's say for data setup or authentication or something else. These code patterns are usually applied to the production code as well, the code that the developers work with. So this is really close to them and they can help and contribute to the project. So in our scenario, this is why we use it, and we try to match the technological stack. So we are again using C Sharp, yeah, with for our test automation. I know this is a bit abstract. When you hear all this, they'll sound like I took it from the marketing website. This is why I want to show you some details about the difference between writing Selenium tests and tests with Bellatrix, so you can understand later how this helped us in our disaster scenario. So let's start first with the test scenario that we have. This is a simple demo page from one of our applications that we use for testing our tests. It's a fairly simple. It's called My Account page. It has a login with some form. The form consists of two fields. Both have labels. named respectively. We have a checkbox remember me and login. So now I'm going to show you how to write a test on this functionality in both scenarios. The first one is I would say standard way to write a test using Selenium, the pure Selenium. And this is a code snippet in C Sharp. Um, the way to write it is very similar in Java or any other language. So I guess you can translate that to the language that you prefer. So the first part here is, before we begin with the test, is to start our browser. Without a browser, we cannot do pretty much anything on it. So we need to provide this setup method, having some annotation, which are specific for any unit, but are available for the rest, to actually start our browser, matching our browser version, and have the driver manager download and set up our WebDriver, which is actually the library we use to communicate with the browser. Okay, so what we did, we just initiate a new Chrome driver, and ask it to navigate to our demo website. Having this WebDriver set, we need some way to transfer it and to reuse this instance. So we are keeping a private field here with the WebDriver, which we can use on the tear down method, which is just closing the browser. That way, we won't have any browsers hanging or any WebDriver processes left over after test execution. Okay, so this is a common setup for a WebDriver test. Now let's jump to the test itself. The scenario that I described is about authenticating, logging in with some predefined user and password. So, a typical test would be to use the WebDriver to actually find element by some locator. In this case, I'm using its ID because it seems legit. Um, After I have the element, I'm sending keys using the send keys method, and I'm typing basically the email. The same thing is repeated for the password, and for the login button, I am using XPath in this case and just going to click. One thing that we can notice here is the way I wrote this test. The first line you can see where I find the element is followed right away with the action that I'm trying to execute against that component. So why I'm doing that? Well, because WebDriver, when we initiate that line of code, if you debug it, WebDriver will try to find the element and it will keep its state as it was at this point of time. The next line, I'm sending keys to it. If there was some difference in between, like some change in the HTML on the markup on the page or some other change of the state of the element, we might get a stale element reference exception and our test will fail. This is a suggestion by Selenium to not get these errors. So whenever you define element, you have to work closely with it, so you can skip these kind of errors. There are many pitfalls around the execution, so I'm gonna try to explain a bit. All right, so I'm doing this. I'm using this approach. Everything is fine. I'm typing the username and password and clicking login button. This is the rest of the method on the next slide. So I'm just starting with the assertions that I have. So I'm using the NUnit assert that some welcome message is present on the page after we log in. And we can see that the logout link is visible on the page. This is done by using the WebDriver property displayed, and I'm doing general assertion for true condition. The next thing to happen here is to click the logout link and to assert that we are on the same page, but the logout link is not visible. As you can see, I didn't implement that method for asserting logout link is not visible because there is no straightforward way like this to make sure element is not visible or is not present on the page. You have to implement something specific, and usually this is the part when, by writing such a simple test, you start thinking about extracting some helper methods and adding some additional functionality either to your assertions or to your navigations or finding elements. So let me show you how this same test looks like in a BELLATRIX. All right, let's begin with the test class. The first difference that you might see is that we are inheriting a separate class. This is a the base class built into the BELLATRIX framework, which is called web test. The web test base class is giving us some standard ways to work with web pages. So these web-based tests are definitely needing some browser setup. They need to close the browser after the test has finished. They would need some to support some different browsers with their versions and some generic functions that any web test needs. So by inheriting this web test class, um, we get some standard functionalities out of the box from the framework. As you can see, we don't have this setup method, which is defining the browser type, the browser version, and all of that. This is already built into the web test. The only thing that we have is the navigation, which is a bit specific in our case to navigate to our own website. So just by overriding the test init method, there are a couple of methods which we can override. You just override the default behavior, which is just to open the browser, and you add to it. So you extend it with navigation to your page. This is the way you can control the workflow of the browser and your test, but in the same time you don't have to fall into specifics, and you can use the defaults from some configurations. This is pretty common for any testing framework. All right, so let's jump to the test. What's the difference there? You can see that first difference is that we have a group of definitions of elements. This is what we refer usually as element mappings. The first one is finding the element for username using its ID, but this time we also have something more. This is the introduction of the control type. In this case, we see that the first one is text field, the second one is password, which is for the password, and we have the login button defined as a button. This is another very specific feature of the framework that it, it gives you the ability to work with predefined components that are typical to use in a web page. This is an example with text field, password, and button, but there are more than 80 controls that are out there, and each control gives you specific methods to work with these components. For example, the text field gives us the ability to set text into it, but the password field gives us a method for set password. The same way, we might have different methods for validating what's written inside of those fields, or if we have more complex control, we can have different methods for asserting and for using them. This is one of the big benefits of this framework, and especially the fact that you can extend that and you can build your own controls that are used in your own project. The other benefit here that we can see is that the group of mappings that we have defined don't have to be close to the execution of the actions on top of them. Why? Well, because by calling the app.components create by ID method, this is just keeping the data from you for what component you want to find, what is its locator, what's the type of it, and also what's the way what's the strategy you want to use to locate it. So having that information, we can just the framework is keeping it in the reference, and at the point where you start using it, it's actually executing the code to find it on the browser and start working with it to set the text. So this is enlarging this lifespan of the variables, and you can extract them either in properties or in some other classes. so you don't have to worry about stale object references. Also, having this approach in place is enabling the test to have built-in weights. So before we use the component, is being weighed for its presence or its visibility. There are different conditions, and then it starts working with them. This is so because of this lazy use of the components. All right, so this is the difference here in the definition of the elements and how we work with them. We have some extra components, we have some extra methods, and we have a more flexible way to define and use our fields. Let's get to the assertions. This is another aspect which is improved over the um, use of the Selenium library directly. The assertions are available depending on the different types of the components that we need. We have different assertions, different validations on top of each component. And for example, we can validate inner text contains. We have a separate method for that. Or we can validate something is visible. Or like in our case, we needed validate something is not visible. All of these methods are available and you can just start using them, or you can override them and somehow modify their work. All right, so this was to give you just some context about how we want to write the tests. And this was also our case. So we had these framework features out of the box, but on top of this, we still needed to do some further improvements. And most of the frameworks, they give you some enhanced methods and APIs for its usage, but you still have to figure out how to apply the best way in your project. All right, so oops, click something else. First thing that most of the people do is to introduce page objects. Adding page objects to your test automation is one of the design patterns that is very commonly used. So in our case, we just extracted our element maps into a separate class. We call it demos account page. So we have properties for each of the components that we want to use. This way, the tests became pretty short, and we can see clearly what we're trying to do. But also on top of this, when we work with multiple pages, executing some system tests, we can easily track what page is doing what and what scenarios are happening on which page. This also gives us some advanced methods like assert navigated. So we don't have to provide the URL of the page. It's already there. And you can just assert that the page has been landed on. To make it more clear, I will show you how Bellatrix page object looks like. So we just inherit from the web page, which is again built into the framework, and we have to override the URL of the page. On top of that, we need our mappings, of course. So we have properties in C#, which are setting how we want to work with the components. These are the locators that we had on the test. But we still have these locators, right? And considering such some large-scale automation, this is really the most fragile part of the system, because the weights are handled from the framework and the navigation and all of that. But any locator that we have is subject to change at some point. Having such page objects, this is giving us the option to update only on one place, but we still have to do it. And if you have some general change, we have to go through all page objects and update them. So another improvement that we tried to make was to start working with the forms based on their visual aspects. What do I mean? So if you have a form which is looking like that with first name and last name, we have labels and we have inputs. The user doesn't know about the ID if he doesn't inspect, of course, but he sees that first name, the label that we see. So we decided to try with this approach and redo the locators that we have for forms. Instead of using the names and the IDs directly, to implement them from the label text to get the for attribute. This is just one implementation, but from the name, first name of the label to fetch the attribute for, and then to find the element with that ID. In this case, we don't know actually what's the ID, what's the value of this attribute. We just use it, and we can use it even if it changes at some point. Of course, this was in this specific scenario where the element labels were there. They had strict convention how to use them, and I believe this is true for most of the projects when they have multiple forms. So let's see how the page object looks when we introduced such a method. Instead of calling app.components.create by ID, what we do is just to create it by label. We still have the type of the control. So instead of the name like that or expat, we just give it the label that we see on the browser. In this case, it's username or email address, and here it's password, and so on and so on. So it's a bit more human readable, what we're trying to work for. And also it's helping for readability of the errors that we see after something fails. All right, this might be good improvement indeed, but it was still not enough in our case. Why? Well, because we still had 2,500 pages that had different, all sorts of labels and names on them. So it was still hard to update all of this and to keep them all intact. So we had to go with even further with the abstraction of these tests. And this was done by using the so-called metadata objects. It sounds a bit uh, fantastic or too complex, but all it is just C# class that has a couple of properties. In this case, each property is representing a field on the page or something like the header of a grid or a table. Let me show you how. This is a sample class that we use for such a model. The first thing we see is that these are just two properties. They have a return type, which is a string. In this case, it's integer. It has property name, and we have a couple of attributes on top of them. In order to use these metadata objects, we decided to go and implement features that can read these metadata objects, these properties, and to understand what is the control you're trying to work with in this case. So having such a model passed to the framework, we know that we are trying to find an element with label named month, and the control type of this element is actually date picker. So we have to pick some date. The return type in this case is string. It can be date time in this particular scenario. And in the savings, for the savings field, we have a field named savings. It's returning integer, so probably we're keeping numbers inside of it. It's not having any control type, which means it defaults to text field, which is the most common field. So we don't have to copy it over and over again. So such a metadata object can be used to keep some values inside of it, but it also can be used for assertions and for setting any data inside of the form. The actual filling of the form is done with a method like that, which is the same method used across the whole system. This method is taking the metadata object, which is just a new class with some data, and it's calling the fill form method. The fill form method itself has all the complex logic inside, which is understanding what is the control type, what's the name of the field. It knows how to find the element based on this convention that we have, and then to actually return the element or set its value. The key thing here is that it's common for all the forms. So when we have metadata objects, we can also work with tables. Bellatrix has really feature-rich table and grid components. So in the case of components, we can imagine the header names uh, as labels in the forms. So instead of label name, we just have header name, and these models can again be used to work with these tables, either for fetching some data by getting some cell or getting some row from the whole table, or for some assertions. This is the way we define some table in the framework, and uh, there are really lots of methods that we can use on top of them. All right, so let's see how our test is looking after we add this generic page objects approach. Instead of having the page objects and calling its properties, all we need to do is to initiate this login page form model, which is the actual model for the page. It has a couple of properties where we want to set the email and password. And this model, we're just passing to the submit form method, which is handling the um, setting of the data into our form. After this has finished, we can validate the greetings, we can validate the logout links, click and do all the rest of the stuff we need. But we don't have any locators here visible on the page, and the page object model is looking like that. We have the login page for model here set as generic parameter. We have the overridden the URL, and you can see that the two mappings that we had initially for the username and password are missing. They're part of this. This doesn't mean that we don't have any element mappings, but we only keep the maps that are specific for the page and are not part of the form. In this case, this is the greeting, content div, and the logout link. So we still keep this, but big part of the element maps are moved to these models. Of course, we can add validations and other methods here on the page object model, but now it looks much more concise and readable. You can also see that we have a base demos form page. I will just skip that part for now because I don't want to overwhelm everyone. You might scratch your head a couple of hours to see what's going on there, but I have everything in my repo, so I'm going to show you how to use it. So, speaking of this, we got to the point where we were living in some nice little bubble with all these abstractions and everything in place that it would help us to survive any change on our website. This is great, but then we saw what's coming. And on one of our daily meetings, the QA manager came to us and said, "You know what? Um, there's some small project going on for about a year already, which we have to start to test. And you know these 2,500 pages that we have, we actually decided to make them single page altogether. So instead of having all these pages, we rework the whole application to become a single page application." This was a bit mind blowing at first, and I started thinking how would be possible to transfer all these tests with all the code that we wrote to such single page application. They said, "Don't worry, everything is fine. The front end should look the same. This is a requirement for this project. So all the components should look pretty much the same to the user. The only change is what happens behind the scenes. So instead of sending some HTML requests for each page, we're just sending some JSON and re-rendering the page without refreshing." And on top of this, they have thought through this process and created some matrix. This is a matrix of the locators that are going to change. And in some cases, we had some classes that have been transferred to data test IDs, which are attributes in the markup. So we know how to change our tests and locators. But there are some cases where the controls were not available and they were still thinking how to do it. Or they decided to change the provider for using React components. So all of this took me to the thought that this won't be a small change and we have to really think about how to implement it. And actually this matrix, as you can see, the 10 rows here were actually 16 pages with all the mappings that are going to change. It was quite huge. But we had a plan. After all, I clearly stated that we have built this really complex framework and all of that just to support such a scenario. So we have to make it work. We'll probably have to do some restructuring, but this should work. And this is what happened. First thing we did was to start with the solution refactoring. The first thing we did was to extract some of the everything that was working with element maps in terms of controls of components like um, single pickers or maybe some text inputs, color pickers, date pickers, everything related to controls to be extracted into a separate project. That way, we can create a mirror of the same project, but implement the only the locators to support the SPA implementation of the project. We decided to keep the existing tests as code legacy version of the test and to have another one for SPA because we didn't know for how long these are gonna live. It turned out to be a project spanning across multiple years, so we had to support both versions simultaneously and somehow to continue our work on daily basis. And it was time for action. We fastened our belts, started thinking how to implement everything, did the refactoring, and implemented all the controls separately just on these component test levels. After everything was fine there, we took a look at what will happen to the pages and to the models after this refactoring. And the great fact that we found was that the page objects that we had in our tests was actually not changing at all because most of the mappings were handled using this generic way with the models with the metadata. The pages didn't have anything to change besides the usings and some base page. So this is a fairly simple find and replace across the whole project, and this would give us a new page on the SPA rendering, which is totally usable. Looking at the models that we had across, we can see that again we have now no changes, not to the project, not to the control types or anything. All we had to change is the namespaces, and actually in this case we're using a select component from the single page applications rendering, and in this case we're using one from the legacy rendering. So these are two separate different components that we use behind the scenes, and this was great success. I can say we declared victory, but victory is not something that you measure with tests executed or test passing and failing. It's measured by the number of and the amount of defects that we were able to find. This is a snapshot of one of our boards over the course of the project. So you can see that we not only managed to convert our tests to align with the development, which was going on for 1 year, but we actually went ahead and we were ahead of development with a couple of months, covering and being able to test modules that they didn't even touch. So we started executing tests across all the modules. The whole regression suite was used in our analysis, and we were able to get great pace at finding defects that needed resolving. So over the course of the project, this was further used for estimations, for figuring out how much time it would take for the next modules to work on, and it was great benefit for the whole project in general. One side effect that we didn't realize we can use was the fact that we were able to measure also performance with these same tests. So having the tests run, we were able to measure every page load using a plugin in the Bellatrix framework. So this is not touching anything in the code besides the base classes and without touching anything on the tests. This was just a functionality that we used. So I have prepared a demo which we don't have time for, but you can clone it from my GitHub account, and you can play around with the implementation because it needs your look on the code. To say in summary, in large-scale automation projects, the level of abstraction is really the key. When you develop something small, you can stay away from that many abstractions that we did here. But when you work on such a huge scale and you want to make the code reusable as much and not so affected by changes, you need to think about abstraction and how to incorporate it into the project. Keeping balance between the readability and code reuse really depends on your use case, but in these large scale projects, it's a must. Also, the well thought architecture is always paying off, especially in situations like that. We knew the framework is hard to at first understand how it works, and it took people some time to get used to it. But in cases like that, we were able to switch really quickly and start feeling it. Everything is good. Also, the framework was built with really some thought and lots of time into it. So it's actually solving issues for you before you start it, and before you see you have them, and having extensibility in the cases like the performance plugin gives you the ability to extend it for your needs, no matter what you need to do. All right, so that was it. Thanks everyone for your attention. I hope it was interesting to all of you. I'll be happy to answer any questions.
Hello, thank you for that. So we have a couple of questions. One popped in while you were showing some of the methods. So I think someone wanted to just know the difference between set text and set password methods.
Yep, that's a great question. And in this case, there is no difference between these two. But we actually have the exact same method for really complex controls like a single picker. A single picker is like you type text, you press some button, some pop-up opens up. So then you have to pick some value inside of it. You have to click that, then submit OK, and it prefills the value. So having the same method for such a complex scenario is really great help for us, because the complexity of what exact steps you need to perform is hidden inside of the framework, and you don't have to care about it because the user is not doing it. So in this case, between the text field and the set password, there's no difference. You just send the keys after all with Selenium, but it could be really different in terms of workflow and actions to be executed.
Makes sense. And then someone questioned your use of Jenkins over Azure DevOps um, because they said, can't you just use test projects also in Azure DevOps?
Yeah, that's possible. We actually tried using entirely Azure DevOps for our needs, and it was working for some time. But in the current situation, we had a pool of agents that we were using for builds, which are for the production code, and we were kind of using the same for our test execution. This heavy test suite is taking, as I said, about 20 hours to complete all the tests. So we cannot keep the resources that much. And actually, we still needed some flexibility that Azure does not provide. The stuff you can do in Jenkins for testing and test automation and analysis of results is really richer than what we have in Azure, even with its extension and the test projects there in there. So we found a way to incorporate these two, still to be able to run the tests from Azure, but not to keep the actual agents alive, so they can be used for someone else while the tests are running. And at some point, when the results are ready, they're coming back to the Azure DevOps to see the actual results. And when you need analysis, which is further analysis on the results, you can go to Jenkins and use system like Allure or some other reporting solution to really get into the details of what happened.
Cool. Thank you very much. And that's all the questions that we have in the Q&A. But obviously, if people want to reach out to you, then you can see your details on the screen. So do reach out if you have any further questions. So thanks, everyone. See you at the next
Yep.
talk.
Thanks, everyone.